is transmission gate. Transmission gate here, it is a basic for construction of any kind of CMOS structures. In the previous lecture, we have studied about pass transistors, how the pass transistor will be passing the signal from one state of the transistor to another state of the level of the transistor. But here now in this particular lecture, we'll be studying about transmission gate. Transmission gate is nothing else but where you'll be using two type of transistors. One is PMOS and the NMOS transistor, which are connected in this manner, where they will be connected in parallel manner, and this kind of construction is called as a transmission gate. So the parallel combination of a MOSFET is known as a transmission gate. It also called as a pass gate. So now this circuit tells about what is meant by transmission gate, how the transmission gate looks like. So now see now, for the PMOS, the control signal which you use over here will be bar control signal, means what are the input you give will be complement to the input given at the NMOS gate. This both the inputs which are given at the gates of NMOS and PMOS will be complement to each other. If you give 0 over here, it will be 1, and if you give 1, it will be 0. So both will be complement to each other, and this is the actual input signal which you want, or the information which has to be passed through the transmission gate. If you supply some input over here, that input will be obtained at the output depending upon the controls of this particular transmission gate. Assume that now if my control is equal to 0, if my control is equal to 0, then what happens? Definitely this one becomes 1, and this is going to be 0. Now at this point of time, you cannot expect any kind of information to be passed from A to B. If my input is equal to 0, that's my control equal to 0. What happens? If control equal to 0 means I'm talking S is equal to 0, then S bar becomes equal to 1. So whenever S bar equal to 1, that S bar is connected to PMOS. So the PMOS is turned off, and here S equal to 0, and even the NMOS is turned off. So in this state of condition, both the transistors are in the off state. It cannot pass any kind of signal right from input, right from this point A to point B. For the next phase of operation, whenever the input equal to 1, the control input, there's a S equal to 1, what happens? This is going to be on, and even this is going to be on. Only at this phase of time, your input will be either passing through the PMOS to B, or else it can pass through the NMOS to B, depending upon the mobility of the charge carriers. It can pass either from PMOS to B, or from NMOS to B. So now let us see this operation right now here in this what has been given over here. A transmission gate consists of PMOS and NMOS, and a control signal which is applied to the NMOS transistor, and its complement is applied to the PMOS transistor. Transmission gate is used as a bidirectional switch. It's a bidirectional switch. First of all, it's an important objective. Transmission gate is a bidirectional switch which is controlled by a command which is called as a control, or else in some of your textbooks, the authors might even write it as enable. En and En bar will be given in some of the textbooks. Don't get confused over here. The control can be named as anything. It can be yes, or it can be named as enable. So controlled by the control signal. Whenever the control signal is high, both the PMOS and NMOS are on. Whenever the control signal is high, whenever the control signal is 1, both the PMOS and the NMOS will be on. During this phase of time, what happens? And proceeds a low resistive path. Means what? Whenever both are turned on, the resistance will be very less. Why? Because a channel has been created, so it can either pass a signal right from PMOS to through the PMOS to point B, or it can pass the information from NMOS to point B. So it can low resistive path has been created so that it can pass the information from point A to point B between the terminals A and B, and vice versa. Vice versa means whenever the input equal to 0, whenever this control signal equal to 0, if S equal to 0 and S bar becomes 1, both the transistors will be turned off. Whenever both the transistors are turned off, a high resistive path has been created. It means a channel is not there. A channel is not being created. Because of that one, information cannot pass from point A to point B, either through PMOS or through NMOS. The compact transmission gate, TG is a transmission gate. Transmission gates are very compact structures, require minimum number of transistors. This is one kind of symbol which you can use for the transmission gate, or else this another kind of symbol. It is also been used as an transmission gate. Let us see now this transmission gate by in order to construct some few logic structures which are studied, logic gates which are studied. A transmission gate consists of PMOS and NMOS transistor, and a control signal will be used over here. So let us see now. Let us try to use this one in order to construct this OR gate operation. See, this is a structure in order to design an OR gate with respect to this transmission gate. This is one of the transmission gate. Transmission gate is used, and here is one structure is used. Transistor has been used. So see now. If input here it is A bar, depending upon this input, whenever this A bar is there, then definitely depending upon what are the signal you are supplying, only whenever this is what like as I told here in the previous case, this your transmission gate will be working. A transmission gate will be working whenever this is high state. If you provide that is a high state, whenever the input is high, then on the transmission gate will be working. So now depending upon that one, if the input which is supplied at the controls of the transmission gate is high, then only it can pass the signal B to the point B. And here, depending upon, see, if it is a high state, depending upon this, what are the control signal that is also connected to this transistor. If this transistor is turned on, then only the A comes over here, and the operation will be OR operation, that is A plus B. It's a combination of input A plus input B takes place over, it becomes A plus B operation. You can even verify this one by putting the truth table of OR gate, and you can do that one as an assignment in order to check whether this circuit is acting as an OR gate operation or not, as per your logic gates. The applications of transmission gates, it can be used in OR gate, XOR gate, and this is a structure for the XOR gate. Here, where in the OR gate we have used only one transmission gate. When it comes to the XOR gate, we are using here two transmission gate. Two transmission gate means what? We are using like nearly 4 transistors and two inverters which again act as an 4 transistor. With the help of only 8 transistors, we can construct the XOR gate. But in the previous lectures, you have studied about XOR gate operation. If it's an XOR gate operation, you can see here how many, if I talk about this one, 6 and 6. Nearly 12 transistors you need to construct an XOR gate by using the CMOS structure. But when you come to the transmission gate, you need only 8 transistors over here in order to construct a XOR gate. So that is the main advantage of using of transmission gate. By using the transmission gate, we can implement any kind of logic with minimum number of devices than compared to the CMOS structure. That's a basic advantage of transmission gate. Next one, we'll see about the 2-input multiplexer. This is a structure for the multiplexer. You know that it will be multiplexing the input A and B depending upon the select line. Depending upon the select line, this is a structure for the design for the multiplexer using the transmission gate. You can even take down this diagram, and you can see that you can check whether this structure is acting as a multiplexer or not. This is ultimately this will be your formula for the multiplexer, and you can see that both the truth tables which is been obtained by using a transmission gate multiplexer and CMOS multiplexer, both will be same. But the only difference is that whereas the CMOS multiplexer will be using more number of transistors, and this one is using a lesser number of transistors. Hardly it uses like 6 different transistors. 3 PMOS and 3 NMOS are used here in order to construct this multiplexer, 2-input multiplexers. Whereas in the CMOS structure, it need more number of transistors in order to construct that multiplexer. So the next topic is tri-state inverter.